Welcome back to Math 104. Within what range would a student need to score in order to be in the middle 40%? As always, we start with a picture. There is some region in the middle here that contains 40% of all the scores. It has a lower bound and an upper bound. That upper cutoff, is some unknown value z. That means that the lower cutoff for this range of scores is negative z. If you score close to the mean, but somewhere between negative z standard deviations and positive z standard deviations away from the mean, then you're in that middle 40%. More specifically, there is a sliver here on the left containing 20%, that is, there is a 0.2 probability that a randomly selected score falls between negative z and 0. And then there's another 0.2 probability that a randomly selected score falls between 0 and positive z. Our job is to work backwards from the table and figure out what value of z would give rise to 0.2 as this probability. We look in the table hoping that 0.2 will appear. It doesn't exactly appear, but there are two values close to 0.2. 0.1985 is close to 2, 0.2019 is close to 2, although not quite as close. Both are in the 0.5 row, so that the true value of z that corresponds to a probability of 0.2 equals 0.52 something. It's somewhere between 0.52 and 0.53. There are approaches to these kinds of problems where you would average 0.52 and 0.53, and there are more refined approaches than that. What we're going to do, for purposes of this course, is just pick the value in the table that is closest to 0.2. It's true that that introduces a little bit of error, but not much, and it makes the process much simpler. So 0.52 is the value of z that we are going to work with as our cutoff. Here we write z equals 0.52. That means that negative z is negative 0.52. And now we want to understand what actual scores on the SAT correspond to this many standard deviations away from the mean on either side. When z equals negative 0.52, we compute the corresponding score as we did earlier. We are solving for x in this equation. Z-score equals unknown minus the mean divided by the standard deviation. This comes out to 452.64. Then when we do the same for positive 0.52, again solving for the corresponding actual test score, we obtain 575.36. Thus the range of scores is between 452.64 and 575.36. In practice, that means that 453 is within this range, but 452 is not. 575 is within this range, but 576 is not. In a group of 100,000 students, about how many can we expect to score between 450 and 550? We earlier computed the probability that a score is between 450 and 550 equals 0.3271. The key here is not to think too hard about this question. To say that the probability that an individual score falls within this range equals 0.3271 means that in the long run, 32.71% of the students are going to be scoring within this range, and 32.71% of 100,000 students equals 32,710 students. You can think of it this way. A student either scores within this range between 450 and 550 with probability 0.3271, or doesn't score within this range with probability 0.6729. This is a Bernoulli trial. Each student's exam performance is a coin flip, which either comes up heads with probability 0.3271, or it comes up tails with probability 0.6729. What we're really doing here is applying the NP shortcut. We're finding the expected number of students. We're finding the expected number of successes in 100,000 Bernoulli trials, where a success is falling within this range between 450 and 550. We're now able to come back to a question we posed in the last set of videos, and that's how to make what you could call apples-to-apples comparisons. Here's an example. 3 friends are taking different sections of the same course. Since different exams are given in different sections, grades are based on how far above or below the section mean the student scores within his or her own section. we assume here that in all sections the exam scores are normally distributed. The three friends are Alex, Chris, and Jordan. Alex received an 82 in Section 1 with mean score 75 and standard deviation 4.2. Chris received a 64 in Section 2 with mean score 50 and standard deviation 8.1. Jordan received a 70 in Section 3 with mean score 60 and standard deviation 7.1. The key question is, who had the highest relative standing in his or her own section? In other words, of these three friends, which one scored the greatest number of standard deviations above the mean in his or her own section? First, let's find how many standard deviations above the mean Alex scored. A raw score of 82 in a class whose average was 75 with a standard deviation of 4.2 is approximately 1.67 standard deviations above the mean. When we go and look up 1.67 in the table, it turns out that this probability is 0.4525. There's a 0.4525 probability of scoring above the mean but below 1.67. Now, the answer is not 0.4525. This 0.4525 pertains only to the region above the mean but below the cutoff. There's also all the territory below the mean, because we're asked Alex received a score better than approximately what percentage of all the students. The students below the mean are half of them, assuming that the scores really are normally distributed. So the answer here is 0.5 plus 0.4525 equals 0.9525. In other words, 95.25%. So Alex performed very well indeed. Chris received a lower score, a 64, but that 64 was in Section 2, where the mean was also much lower. At the same time, the standard deviation was much higher. So 64 minus 50, all divided by 8.1, is approximately 1.73. Chris scored 1.73 standard deviations above the mean. When we look up 1.73 in the table, it will tell us about the probability of falling in this region between the mean and 1.73 above the mean. We'll still need to include everything below the mean. Thus we'll have 0.5 from this region, plus another 0.4 something from this region, namely 0.4582. Thus the sum of 0.5 plus 0.4582 equals 0.9582. In other words, Chris outscored 95.82% of the class. Also a very strong performance. Because Chris scored more standard deviations above the mean than Alex did, we see that Chris's performance was a stronger relative performance, but we would not have known that without going through all this computation. Before going on to the next video, answer the following questions. Jordan received a 70 in Section 3 with mean score 60 and standard deviation 7.1. Jordan received a score better than approximately what percentage of the students in Section 3? And, of the three friends, which one had the highest relative standing in his or her section, and which had the lowest?